Hi, everyone. Welcome back to another Jakarta Tech Talk. I'm your host, Laura, and I'm here to introduce our guest speaker today, Tim, who will be presenting about Microprofile and Helidon. If you have any questions, please leave them in the Ask a Question button below, or you can ask them in the chat box. Over to you, Tim.
Thanks, Laura. Hello, everyone. So today I'm going to talk about how you can build microservice using the microprofile and the Helidon framework. So I'm Sam. Good morning. So before we get started, little background about me. So I'm a Java developer and I'm working as a full-time employee in Software AG. I'm an API evangelist. I talk about API and API best practices and API programs a lot. Apart from my regular work, I'm a Madras Java user group lead and I'm married. I'm having 2 kids. And when my free time, I usually blog on technologies. Recently, I'm fascinated about the garden engineering. So trying different things with gardens and all these things. So what we are going to discuss today. I hope you all know some understanding about the microservices. So I'm not going to cover in detail about microservices, but definitely I'll cover what is microprofile and why microprofile is so important. And then I'll move on to a Helidon framework, which is the microprofile compliance framework. And then I will give you a walkthrough on each and every specification driven in the microprofile. First, we'll start with what is microprofile. So microprofile is a programming model to develop microservices in the enterprise Java world. So it is completely driven by the community and there are lots of good things. It's taken from the Jakarta EE framework and it is built on top of it. And it also offers lots of cloud native development practices, something like the health check and fault tolerance. All these things will come into the picture. So we'll go deeper. And there are lots of active contributors behind this microprofile initiative. So just to name few, we have IBM, Red Hat, Tommy Tribe, Payara, Oracle, Microsoft, and many more. So why microprofile is so important now? If you see few years back, the enterprise Java development, there seems to be a complaint that it is heavy and it is very hard to build application and it bundles some most of the unused libraries. There are lots of hiccups here and there. So the main agenda behind microprofile is eliminate all these burden when you develop the microservices, and you don't need to learn anything new apart from your existing learnings. So if you know Java and the Jakarta EE learnings, then you can take those learnings and you can get started with the microprofile development. And you can choose your vendors, meaning there is no lock-in with the microprofile implementation. If you code or if you develop your micro services based on the specification, and then you are free to move between different implementation vendors. So there is no lock-in with the vendors, and there are multiple ways of using their APIs, especially they offers CDA support, and you can also interact with through program, and they are also offering CLI. And it is completely specification driven, meaning every the decision is made through the community process, and all these things will be reviewed by the community, and it is completely backed up by the community. So everyone is free to give their opinion, and you can also improve all the microprofile standards and everything. So that is the beauty behind the whole ecosystem. Okay, we have seen why microprofile is important and what is microprofile. Now we will go a little deeper and the current version of microprofile. What is all about microprofile? So underlying is the simple and well-known Jakarta EE good parts. So if you see in the four boxes, CDI, everybody knows CDI and JAXRS, JSON B and JSON P. All these are fundamental to build any web services in the Java ecosystem. So they have taken these core pieces as a fundamental component, and top of it, they also offer lots of cloud native specification on top of it, especially the configuration, fault tolerance, health check, JWT auth, metrics, and open API, tracing, and risk client. So today, I'm not going to cover the JWT auth. Other than that, all the other parts I'll be covering. So on top of it, so the complete annotation support is available for your development, just to ease or simplify your development lifecycle. So there are three things is marked in the orange color. There is a specific semantic behind that. These three specification is modified or updated from the earlier microprofile specification. That's why I have marked these three things alone in a different color. The remaining things, there is no change. Okay, so we have seen the microprofile specification. Now, who is supporting or who is offering a different kinds of framework to build our microservices? So as we've seen earlier, there are plenty of opportunity we have in the market right now. So we have Quarkus developed by Red Hat, and we have OpenLiberty supported by IBM, and we also have Helidon. Of course, today I'm going to cover Helidon. So Helidon is being developed by Oracle. So likewise, we have many different vendors. They also offer different kinds of framework. All these frameworks are completely compliance with microprofile. Okay, now we move on to the important topic, Helidon. And let me spend a few minutes to explain what is Helidon. So Helidon is all about a microprofile implementation framework. It is developed by Oracle, and it is completely supporting Docker and Kubernetes from day one. Meaning nowadays everybody is going with the containerized deployment model when it comes to the microservices. So they are supporting this from day one. So they, when you create the skeleton code, they also offer these kind of skeleton code along with the generated codes. And it is completely powered by Netty, one of the reactive web server available in the market. And they have two different variants in the microprofile. One is the microprofile variant, and another one is the standard edition. And they also support the GraalVM engine. So if you generate the native binaries, you can directly deploy into the GraalVM engine. Okay, now we will dive deeper into the how we can get started with the real framework. So this is simple Maven archetype. So you can customize it based on your business need, and you can change the package structure and the group ID and everything. So once you execute this, you will get the skeleton code, which will be downloaded into your system, and from that you can get started. If you are not comfortable with executing the this archetype, then they also offer a different UI. So this one was launched recently. So if you visit start.microprofile.io, you will get the nice UI, and where you can fill the necessary information. And the moment you click the download button, your binary will be downloaded, meaning your skeleton code will be downloaded, and you can get started from that. So basically, if you see in the right side, there are few options is mentioned. So you can pick and choose which library you want to include in your microservices development. If you don't need the open API or the open tracing, then you can just uncheck, and only those dependency will be bundled in your final binaries. Okay, so I'll get started with this simple JAXRS web services. Everybody is talking about microservices, so we also build some microservices from that. So I have already created a skeleton code by executing the Maven archetype. So this is already imported into my IntelliJ editor. So you can use any editor based on your comfort. So I'm using IntelliJ, and I'm comfortable with that. So this is the basic skeleton code is generated, and if you see the main file, so they are generating a simple server and they are starting it. So this is the starting point, and once the skeleton code is ready, we'll check whether this is compilable or not, and I'll just execute this maven command. Yes. Yes, it is compiled. My build is successful. Then you can start the server using java minus jar and with the final output of my helidon.jar. So this will internally start my server with the port 8080. Okay, my server is started. So as I mentioned earlier, so we'll get started with building some RESTful web services and how we can handle exceptions in the web services and how you can generate some links and few example with that. So for that, I will open a simple service to explain this concept. So this is the interface. So I usually start with the interface and then do all the annotation in the interface, and then my implementation code will be very clean. So this is how you can create a simple web services. And here it's a ping service which has two methods. One is ping and other one is the welcome message. And if you see implementation, there is nothing. I'm just returning some messages. In this I'm just returning a hard-coded message, and in the welcome message, I'm just taking something from the configuration. So I will cover this in the next. Okay. So let me check whether this is working fine or not. So I'm just checking my Postman, and this is my ping service. Just clicking. Yep, it is working fine. So we have seen how we can create a simple web services using JAXRS specification, and next we will see how we can handle the exception part. So for the exception, so it's for every business we may
I'm
have.
sorry.
Yep.
They're just asking if you can enlarge your text a little bit.
Okay.
It's
Just a
looking
minute.
a little bit. Thank you.
Yeah. No problem. Just a minute. I'll increase the font size. I hope this would be clear now. Okay. So this is my business exception. So whenever we build some application, we need to build some custom exceptions, and how these custom exceptions could be handled by the JAXRS specification itself. So this is the exception mapper, and if you see here, so the this exception mapper is bind with my custom exception, and this is annotated with provider as well as the producer's JSON media type. And if you see here, this is how I'm generating the response whenever my application throws some exception, and automatically this exception mapper will handle all my exceptions. So I don't need to generate the appropriate response based on these exceptions. So it's all, I'll simply throw this exception from my code. So if you see here, so this is the country API, and if you see here, so this will be thrown. So if you go to the postman, and I'm just getting all countries. Yeah. So I will explain how handling the exception part. So if you see here, this exception response is being thrown from my exception response handler. So if you go to the this exception mapper, so basically my country API, if something is not, I'm having a manager, and this manager is not able to identify based on the code, so I'll throw an exception. So either this code is null or the code is not able to identify a country, I'll throw an exception. So this exception will be automatically identified by this exception mapper, and it will be transferred to the client. And the next one is usually whenever we create some object, we will send the link part just to maintain, or just to give the indication to the user how you can navigate to the appropriate resources once you got the successful response. So this can be easily achieved using the link API. So we have a simple link generator here, and this link generator will get the path from the URI info, and it will append the slash, as well as it will add the self reference, and based on that it will be injected into the response header, and from that header you can get the response back, and you can process accordingly whenever you want to try generate some link for a created resources. Okay. Okay, so I have covered the JAXRS part, and I will move on to the configuration part. So this is one of the important and very interesting topic when it comes to the microservices development. So if you remember the 12 factors for building an app, that is the best practices is being advocated by many industry leaders. So if you see that they are advocating one important component here is the configuration, meaning you should be able to transfer or pass a configuration externally I mean from the external field. So as part of the micro profile, so they have defined 3 layers of configurations. They are referring that like config source, and it is started with the microprofile configuration and the environment configuration and the system level configurations. So if you closely watch the slide in the right side, so I have put some number within this bracket, so meaning this is the ordinal number, ordinal factor. So based on this number the priority will be defined. If you see here, the microprofile ordinal number is 200 and the system ordinal number is 400, meaning whenever you pass some variables at the runtime, so that will take the highest precedence than the microprofile variables. So this configuration is available as part of the resources folder. So whatever the application level configurations you can add here, and you can bundle it along with your application. So I have few where configuration. It's a simple property file, and so you can add any number of properties, and you can load when the system starts. So I have mentioned also server port and the host, and some of the properties. So how I can access these configuration properties inside my code. So a micro profile offers two different variants. One is the config property, and the other one is the config annotation. So the config property is mainly used to access individual properties based on the key. So if you see this example, so app.greeting is a key available in the microprofile property file, and which is accessed through config property annotation. But in some cases, we may need more than one properties at the same class file. So to address that use case, they have introduced something like config annotation, so through which you can get all the configuration property reference at one shot. So I'll just show the code how you can achieve that. So if you open this ping API, so I have injected. So all these injection and everything is supported through CDI. So you can just inject this config reference, and it will be automatically injected into the code. And from this config, and I can call the get value with the app.welcome. And you can pass the value type. So in my case, it's a string, but you can also do integer, long, or whatever it may be based on your requirement. So this one can be accessed from welcome. So I'll just change this thing. So see, I have not passed any variable here. So in this example, so this config property expects some kind of variable here. So the variable has to be passed with this query parameter. So if I pass this query parameter, so this will be automatically injected into this variable, and we will get the final parsed string. And then now I will show you how we can change some of the in a bundled property from the external world. So for that, I will take this key. So I'll stop the server, and before I start this server with the -d flag, so it is currently showing welcome Helidon. So I will change this to hello. Okay. So I'll start the server. Now I am passing some variable through runtime. So you can also define your own custom config sources, and it can be attached to your application. So it can also read the config file from the database or some static files. So those things can be handled at the micro profile level. So my server is started now, and if I hit this, it should return hello Helidon. That's what my expectation. Yes, it is working fine. So this is how we can pass some argument to change the configuration which is available at the microservices level. So this is where this ordinal factor will come into the picture and it will play a role. So sometime if you bundle more than one configuration file, you can also enforce the ordinal factor for each of your property file. Say for example, there is one more property available in the configuration specification, so which is config underscore ordinal. So if you add this property into your configuration file, then that will also be treated when this configuration specification loads the configuration property file into the application. So based on this, it will override. If it finds more than one key across different property file, so the merge will happen based on merge, or the override will happen based on the ordinal factor. That's how the specification mentioned that. Okay, so I hope you have some understanding about the configuration and how you can pass some external configuration and how you can write the config sources and everything. So next, we will move on to the health check. This is again an important component when it comes to the microservices. So each microservices should somehow indicate to the external application or the developers that how my health is. So based on that, if the application owner want to take some decision, the business I mean the business availability decision, then he can span a new instance, or he can also get notification. All these the DevOps cycle can be managed in a smoother way. So for that, the health check specification offers slash health is the endpoint. We don't need to write anything to get that out of the box. It is by default they are supporting it, meaning every micro profile implementation vendor has to offer the slash health API. So this by default this offers three kind of intelligence. One is the deadlock detection and available disk space and available heap memory. So based on this, the JVM level intelligence, we can take some important decision and extend our liveness of our application. So I'll just go through how we can check the health. So this is the endpoint which is available by default, so we don't need to provide anything. So this will give you some indication about the disk space. Just pay attention to this part: disk space and heap memory, and all the other important, the deadlock. Yeah, the deadlock. So these are the three things will be available out of the box. So apart from that, if you want to check the liveness and the readiness, so these are the two changes was introduced in the recent specification of health check. So if you want to check the liveness as well as readiness on your own, so you can provide your own implementation on top of the existing API, and you can get the benefit by this health check API. So we will see how we can get this done. So they have introduced two kinds of annotation. One is liveness, and which is available under health slash live, and other one is readiness API. So which is supported through at readiness annotation. So this is available under slash health slash ready. So I will just access this. I have written something already. So live, if you hit this, you will get the liveness and ready. Yeah. So let me show you how we can achieve that. So for that, so we need to provide an implementation for health check. So I have provided health check the liveness, and other one is the readiness. So these two things, what it does is, so the readiness is annotated with readiness annotation, and the liveness check is annotated with liveness. And if you see, you can name it like anything, and you can also send the status based on some business calculation, and it's up or down based on your need. So currently I'm passing it as up, but you can also do some calculation before you make the decision. So the readiness will always have some calculation. So I'm just calculating the startup. So if you see here, it is just observing the annotation. It's a listener. So when the application scope, it's a annotation available, and when the server boots, the CDI engine will initialize all these things. Once it is successfully initialized, this observes will get some notification. So based on that, I'm just calculating the ready time and how much time it took to get started and everything. So to demo this, I need to stop my application. So here, I don't need to pass this anymore. So I have already demoed this to you. So I'm not passing this. So I'm just starting my server again. If I hit the ready before it start, I'm getting exception. Oh, I saw something, but I want to show you something. Okay. Okay, let me cover that later. So this is how you can provide the health check for your microservices. If you see the code, it is so simple and straightforward. The next topic is metrics. So metrics is this specification offers a unified way for the microprofile servers to export some monitoring data at the management agent. So it's mostly for the developers to have the uniform follow some uniformity across all the microservice development. So they can basically depend on few concrete REST endpoints to check the metrics of the application. So by default, it is classified under three different categories. One is the base, and the other one is vendor specific, and the final one is the application specific. So if you access this, if you want to get some metrics at the base level, so you can pass this metrics. So metrics slash base. Okay, I'm not getting all these endpoints. Yeah, so by default, this will this is follows this pattern. But if you want to change this pattern, you can pass this in the yeah. So it will be transferred as a JSON format. So based on your business need, you can change the response pattern, and you can also consume those API to get the some insights about the underlying heap and all those information. So I'll just call the application level metrics. Okay, so so these are the metrics I'm getting. So how many times the particular API is called, and all these things is possible through this metric. So you can also get some intelligence. So and you can also do all the metering stuff based on your need. So these things is achieved through a simple annotation. So if you go here, so these are the annotations is used for. So one is the counted, and the other one is metered, and other one is timed. So based on your requirement, you can define what type of metering you need, and you can monitor your application. So this is something for the unit for calculating the metrics analytics. Okay, so I hope this also be straightforward to you. And the next one is fault tolerance. If you take any microservice, the fault tolerance is one of the fundamental expectations from the industry. So, meaning fault tolerance is nothing but fail fast. That's what people are claiming, that if and reduce the impact of your microservices. So, based on different strategy of your fault tolerance policies. So, by default, they are supporting five different fault tolerance capabilities. One is the timed out and retry. The other one is fallback, and the next one is circuit breaker, and the next one is bulkhead. So these are the different fault tolerance policies, and you can club more than one or one based on your requirement. You can do all this magic in your application, and you can handle your application in an efficient way. We'll see one by one how we can achieve this in the real time. So let me start with the timeout. Timeout is simple and straightforward. So, say in some situations, if application is waiting for so long, and this may impact the performance or the other request in the server. So in order to handle this effectively, you can also enforce the timeout at the class level, or timeout for each and every resource level. So this is very simple, and this will have few properties. So I'll close, and I'll open few tolerance API. So this is a simple tolerance API I have created for each and everything. Okay, the first one is timeout. So the timeout I have by default is 1000 millisecond. Yeah. So that's how this configuration says. So I am not passing anything, so the default will take in the place. So I am purposefully waiting. I mean, just to simulate that, I am purposefully make my application to wait, and then how the timeout is taking place, and it is responding. Okay. So I'll tab. Okay. Okay, so this is responding properly because this is falling under within the scope. So this is responding based on the successful response defined here. So I am passing. I am increasing the threshold. I'm just forcefully making my application to wait. So this will throw a timeout exception. So I'm still I mean uh, seeing this in the console, but let me show you how you can handle this exception by accommodating the other annotations in the future. But right now, this is just to explain how and what will happen when the timeout exception is arised. So when there is an exception, the timeout falls under place, it will throw a timeout exception. Okay. So, but in real time, we need to handle this exception gracefully, right? So for that, we can attach some of the other capabilities offered by the fault tolerance. So we'll see in this upcoming examples. So the next one is retry. So here, timeout along with retry. So retry is nothing but when the retry mechanism should take place. So I'm indicating that whenever there is a timeout exception, just try to execute one more time, or based on this I mean configuration. So they have provided all these configurations just to make sure that we can extend this all these capabilities in a nicer way. So this indicates how many times this retry mechanism will take place. So if I mention this one, then it will retry once, but I have mentioned this two. So it will execute automatically two times, and then if there is no, I mean, successful response, then it will fail again. But in between, if I am able to recover my system, then I will get a successful response. So that is the whole intention behind that. So I'll just see how this behaves. So this one has an endpoint with retry on. Okay, so I'll scroll down a little bit, or I will stop and start. Yeah, it started, and I will mention Retrial. So okay, there are two times. Sorry. Okay, so I'm getting the successful response here. If you see the console, and it is enters to the method, and it the sleep time is 1 minute, so it is giving the successful response. Now I'm increasing the wait period. So just look into this console. So how many times it is actually retrying based on my configuration. Okay, so I'm just sending this request, and definitely this will fail. Yeah, it failed, and I will take you to the place where I stopped last time. Yeah, so this is where the first one, right? And then this is the first request for 5 minutes waiting period, and it tried, it failed, so it threw the timeout exception. So based on this configuration, so I have made the configuration as two, the maximum retry two, right? So based on this configuration, so it tried two times, and even within two times it didn't get any successful result, so it failed again. Okay, this is how you can do all this mix and match of timeout and the retry and all these things. So delay is nothing but between the retries, what is the wait period I should enforce to the system. So it should not be very frequently. If we retry, the chance of success might be very low. So I'm just giving some time slot to delay my next time slot to try. So you can also configure this based on your requirement. So next one is very interesting. So we'll see how we can club timeout with fallback method. So fallback method is nothing but to improve your efficiency of the success rate whenever there is an exception. So for if you see here, the fallback, they offer two different flavors. One is the fallback handler, and the other one is fallback method. We'll see what these means and how we can get the benefit out of it. Let me explain first the fallback handler. Okay, so if you see here, the fallback handler, so I have configured some class here. So what does that mean? So we need to pass one fallback handler implementation. So this is the interface. I have provided one implementation. So this is the fallback handler, and this will provide some kind of response whenever there is an exception. Whenever there is an exception for this method, so for timeout, so this timeout exception happened, and then this fallback will be triggered. So what this fallback will do is, this will have some kind of response. So I have currently generating some dummy response, but in real time business use case, based on the error or based on your requirement, you can change the response and you can send it back to your client. So we'll see how we can see this in action. Fallback handler, timeout fallback handler. Okay, so I'm just changing it. So first, there is no exception, so I am getting the successful response from my method itself. So if you see here, so this is the response, timeout with fallback handler, right? Yeah, timeout with fallback handler. So I'm getting the successful response. When I increase the threshold, then the response will be changed. If you see here, the response from Helidon from bar fallback handler. So meaning whenever there is a timeout exception happen, this one give the control to the fallback handler. So please handle this exception. How you take this decision? So the chain, the request chain will follow the fallback handler. The fallback handler actually generates my expected response. So if you see here, the same result I'm able to see here as well. So this is how you can improve your application efficiency by accompanying both timeout and the fallback handler. So the next one in the same fallback bucket is fallback method. Instead of fallback handler as a implementation, you can define a separate method and hand over the responsibility to that method. So if you see here, so I'm just mentioning that fallback method, and this is a method name, and this method is available here as a private method. Got it? So so this is again a simple and straightforward. So we'll check how this operation works, and I will change this. First, I'll get the successful response. Yeah, timeout with fallback method, and then I will increase generated from on fallback method. So this is how you can hand over the responsibility to different method or different handlers during some exception, during some exception, in order to improve the efficiency of your application. Okay, let me cover the circuit breaker again. So this is one of the important topic when it comes to the fault tolerance. Circuit break, you all know what is circuit, and by default the circuit will be in the closed state, meaning all the requests will be allowed to reach the appropriate the request handler, and the response will be sent back to the client. So when there is a problem, what this system will do is, it will open open the circuit, meaning no further request will be allowed inside to access the resources. And based on the configurations, there are different configurations they are supporting right now, and based on these configurations, so you can make this application to half open the circuit, and then based on few other configurations, you can again close the circuit, then all the requests will be allowed inside to access the resource. So we'll see what are the different properties is being supported as part of the circuit breaker. So one is the request volume threshold, and the failure ratio, and the success threshold, and the delay. So let me start with the request volume threshold. So this is the bandwidth within that period. My expectation is 4, meaning within the 4, the failure ratio is enforced as 0.75. If it crosses this threshold, then automatically the circuit will be opened. By default, it will be in the closed state. When this principle is violated, then automatically the circuit will be opened. And when the next request, so it will delay for 1 second, and the next request, if it is success, then it will monitor internally, and this is the temporary request, successful request allowed to access the resource in the off open state. So once this threshold is also reached, then it will be completely closed, and then the circuit breaker is not active. So all the requests will be allowed inside. So I will and see how I can simulate. I tried, but I couldn't get the response properly. But I'll check again. So this is the circuit breaker method, and if you see here, this is throwing the proper response back, response from the circuit break, and I'm increasing the threshold. So my if you see here, so I have also attached a fallback handler along with this circuit breaker. So I'm catching here a circuit breaker open exception handler. I mean, meaning I am catching the circuit breaker open exception. So whenever there is a circuit breaker open exception is thrown, this will be activated. So that's how this is indicating. Okay, so if you see here, I'm caching this fallback handler. Okay, so the next one is in this category is bulkhead. Bulkhead is nothing but if you want to enforce the thread pool efficiency, the concurrency and all those things, so you can have the bulkhead annotations, and you can manage these things in an efficient way. So currently the microprofile offers two different way of a bulkhead capabilities. One is the thread pool level isolations, and the other one is semaphore isolation. The first one includes a bulkhead as well as the asynchronous, meaning this will calculate both the maximum concurrent connection as well as the waiting queue. The second one will only consider only the concurrent number of connections. So unfortunately, I have the implementation, but I couldn't have the test to reproduce that. So maybe in the future I will demo this to you. Okay, so this is where you can define the bulkhead 5. So meaning 5 concurrency is allowed, and here I'm just configuring asynchronous annotation as well as the bulkhead with waiting task queue. So here you can also, as I mentioned to you, you can also mention the waiting task queue size is 10. So the 10 requests will be in the queue, and once this one is successful, and then this queue will be processed. So that's how this will work. I hope you have some fair understanding about the fault tolerance topic. I'll move on to the next one, which is the REST client. Everywhere I'm seeing we have lots of client libraries for testing our REST APIs, right? So we have Apache HTTP client, even Java recently introduced from Java 9 the native HTTP client, and you can also write the HTTP from the native URL connections and everything. and there are plenty of HTTP clients to test our REST APIs. But when it comes to the real time API testing, there are plenty of problems: marshalling, unmarshalling, and error handling. All these are complex problems, and if you want to validate some of the response, you need to pass the JSON, and you need to do you need to have all the query and everything. But what is the beauty of the REST client in the micro profile? It is a type space, type safe REST client, meaning we complete Java is a type system. So we write application completely based on the type semantics. So if we get the opportunity to test our application based on the types, so it is so easy and straightforward to test our application as well, because that is the one of the best approach when we develop some application in the Java, because our code should be testable, and we should be able to efficiently test and easily validate our application state. So that's the beauty of the micro profile REST client. So these are the two patterns where you can configure the REST client into your applications. So one is, there is a REST client builder, and through which you can create a new builder, and you can pass a base URI, which is our application host and port, and then the beauty lies here. Some API.class, meaning this is the actual API definition interface. So this will return the actual type, and we can simply call the method and test it. So that's where the beauty lies in. The next way we can test our the REST client is, we can directly annotate our interface or the API definition with register REST client with the base path, and then we can just inject at REST client into our code, and you can call anything, any method available in the interface. So we'll see how we can test some of the API using our core, the REST client. So I have written some sample test code. So I'll take this one. For this, I will also open the API definition. Okay, so this is the API definition, and this is the API test code. So if you see here, countries is the base, countries is the path, and this interface is iCountry API, and this offers three methods. One is all, other one is add, and the other one is get. And if you see the client code, my base path is HTTP localhost 8080, and I am initializing my REST client with the REST client builder with the new builder, and I'm passing the base URI as from the URI builder, and then I'm just building with the interface iCountry API. This returns the iCountry API object. So from that moment, I can simply call the method directly and getting the response back. So we don't need to write any marshalling code or unmarshalling code. Everything will be taken care by the underlying implementation engine. So that is the expected outcome from the microprofile specification. So whoever implements the microprofile, or whoever claiming that I'm compliant with the microprofile, so all the framework vendors has to provide these kind of marshalling, unmarshalling capabilities out of the box. So I'll just execute this test. Yeah, it's starting. Sometimes we need to be patient when we test our applications. Okay. Yes. So this is returning a proper result. So, and if you see here, so I'm just calling the API directly. So country API dot add country, and I'm just passing the bean, and it is adding that. So I'll just call this test. Yeah. So it is also added now. Yeah, the link is generated. As I told earlier. So if I call this again, so the Italy should return. Yeah. Yep. So this is also available here. So this is how we can write a simple. I mean, we can cover all the client API using the newly introduced REST client in the microprofile. So this is so simple and easy for developing our test framework, and we can cover the code in a efficient manner. We can avoid all these things whatever we have in the right now. So this is one of the important component as part of the micro profile. Okay, next one is open api. I believe you all know Open API. So this is a specification for writing your API definition, documentation, or how you can define your API contract and how you can share this to your developers. So it's basically when you target the API first development. So this is a kind of contract where you can define how my API should look like, and what is the request it should pass, and what is the response it should return back, and what is the status code, and what is the payload, what is the schema. All these things will be covered as part of the open api v3 specification. So how this is come into the picture of micro profile context. So by default, the micro profile specification defines whenever you access slash open API, the microprofile implementation vendor has to provide the open API specification out of the box. Such a beautiful, I mean, definition is defined as part of the specification. So we don't need to write a single line of code to generate open api. But if you want to improve open api spec, we need to do some customization here and there. I will explain in a moment how we can do all these things. But just to get started with the open api definition, we just write the API metadata using the JAXRS annotations. So from that annotations, they are automatically generating the OpenAPI spec. So that's how the default part is being covered. So if you go here, and I'll just change this to OpenAPI. So by default, the response is in the YAML format. But if you see YAML is a problem, then you can also change that by passing the accept header. Yep, now it is changed to JSON. Okay, so there are two flavors. One is the YAML format and the other one is the JSON format. You can get the benefit whichever way you like. Okay, so this is by default, this has to be supported by the microprofile implementation vendor. So as a developer or as a company adapting to the microprofile concept, these are the default benefit we usually get that without any effort. The next approach is static file. So I have heard some of my friends is also doing these kind of approaches. So they are generating the skeleton microprofile, and they are handwriting all these definition or changing the definition based on their needs, and they can ship it to the customer. So in this in this context, if you take this approach, you can generate the open API specification, or if you can create by hand, and you need to put it under the meta-inf. And once it is available, then the moment you call slash open API, then this static file will be picked up and shared to you. Okay. And the final approach is, if you are addicted to write some code to generate all the micro profile, the open API specification on demand, then you can also do that. So the specification provides some capabilities to do that. So you have to write an implementation for OAS model reader, and this needs to be configured with the key mp.openapa.model.reader in the configuration property. Once it is done, then your the dynamic code generator will come into the picture, and it will do its job. There are three different flavors I explained, but in real time, all these things will be merged together, and it has its own algorithm to identify where and all it is available, and it is taking the definition, and it is doing mix and match and all these things, and it is finally generating one nice open API definition based on our business need. So we will see how we can do that. So I have written a simple Open API custom implementation. So I'll show you. So this is my custom implementation. So by default, I don't have the information. So what I did was, I'm just generating the information for my requirement. So for the time being, I will comment this, or yeah, yeah, not here. I will what I will do is, I will change the microprofile configuration. Yeah, so I will comment this. Okay, so meaning, so this custom implementation will not be inactive. Okay, I'll just compile. Yeah, I'll start. Yeah, I will access the open API again. So the info is changed, if you notice that. So it's the default info generated by the definition. Okay, but I don't want this. So what I will do is, I need my custom info. So I have added some contact info. So this things is not available. If you notice here, the contact information is not available, but I want to include my contact info and everything. So how this guy changes this definition? So it will consider both the default OpenAPI spec as well as whatever we provided through the custom OASM generator. So these two things will be considered, and it will be merged as one, and it will be given back to the end users. So that's a beauty of the Open API specification as well in the microprofile. I'll quickly rush because we are um, closing to the end. Okay, pay attention to this statement right now. So this info has only two, title and the version. The moment I test this again, and it also includes whatever I added as part of my code, right? So this is one of the enhancement you can do if you want to beautify your API and everything. So, and apart from that, I have also made some changes in the below method. One is the ping method, right? So you can annotate. Okay, yeah, it is very tough. Oh, oh, sorry. So I'll copy the response and I will paste here. I want to show the ping method. I have commented something. Yes, just pay attention to this. Okay, so this is another customization I have added through some of the annotation possibilities. So if I open this, um, yeah, you can also enhance your API definition by annotating these kind of enhancement into the Open API definition. So these things is also part of the microprofile specification. So operations. So I have added a nice description and the response code with the proper description and everything. So this is how you can enrich your API definition and deliver to the customer. Okay, so I have covered now Open API. So the next one is Open Tracing. So this is again one important component in the microprofile specification when you are in the development of microservices. So where if assume that if you have multiple microservices, and if you want to understand how the request is going to a different microservices in a real time, so this will be very complicated for the cloud scenarios. So to address that, the microprofile offers this capability, the tracing, live tracing based on the request happened. So you can also monitor based on your requirement. So currently there are two tracer implementation is supported by the Helidon framework. So one is the Zipkin and Jagar. And for this demo, I'm considering Zipkin alone. So I'm not having any demo for Jagar, but I'll use the Zipkin and how we can get the benefit from the Zipkin. Okay. So for, so for that you need to download Zipkin from the internet, and I have already downloaded, and it's a simple jar file, and you need to start the Zipkin server. I'll start this. So there is one change you need to do in order to bind Zipkin with your application. So Zipkin 5 by default will be running on 9411, and this information, which application has to be monitored and everything, that has to be informed in the microprofile configuration file. So if you see here, so I have my tracing service as Helidon bar. So this Helidon bar is the application name. So if you see here, so that is the application name. See, so that is the application name. So that is configured as the service in the tracing. So from that moment, when I start the server, this connection will be made, and so now the Zipkin is started, and I will also start my Helidon server. Helidon microservice is getting started, and the moment it start, if you notice in the command line console, there will be something, yeah, Zipkin tracer builder. So it is watching on the Helidon bar. So to access this Zipkin, we need to access 9411. Yeah, my Zipkin is running successfully, and currently there is nothing. And what I will do is, I will hit some endpoints. Okay, so I'll ping, and I will also call welcome. Okay, I have called two services, and I'll just refresh. Now my service is picked up here, and I'll search. So see, so here two, I mean, a request is being monitored. So one is this, so you can track what is called, where, when is called. So you can track complete trace of your request. So I am currently running one microservices. So this is not very, I mean, interesting. But when it comes to different microservices and the request, how it is being spanned across different, how the tool chain, I mean the request chain is going on, so you can track all those things in an efficient way. So if it is an error, I will purposefully fail this. um, okay, tolerance. Yeah, it's failed. So this information is very interesting. So it will be shown in a red color. So go here so you can understand in a detailed way. So all these, I mean, the analysis on this tool is so efficient when it comes to the real time. If you want to track in a distributed the request span. So this is all about the open tracing. So it's simple. There is one configuration you need to bind in your microprofile configuration file. So the tracing dot service with your microservice name. So then the application will automatically, the Helidon is automatically identified the Zipkin, and it understand that. Okay, so I think I have reached the end, and thank you everyone. This the whole project is available in the GitHub under this URL, and this is my blog, and I have written many articles about Helidon and Microprofile, so you can go through that. So one before we move into the question and questions, if you have any questions, you can ask. But one disclaimer is, I may not have all the answers right now, but I will definitely find an answer at later point in time, and I will share it to you. So you can get the benefit of the micro profile easy and efficient way. So happy developing microservices using microprofile standards as well as Helidon framework. So till now, I have not used any of the code specific to Helidon framework. That is the beauty, because I have coded everything with respect to the specification. So whenever your company decides, okay, this contract is the licensing terms and condition is not working anymore, so we don't need this framework. So if you want to move something to a different framework, so you can pick and choose whichever microprofile compliance framework, and you can move the complete application to that. You don't need to change any single line of code. So if I want to move this code and run into some other microprofile compliant container, I can simply run because I have no dependency with the Helidon. But Helidon is a framework, offers some capability, so you can get the benefit. So apart from building your application, so they also generates the Docker file out of the box. So I told you in the earlier, right? So they have generated the Docker file by default, so you can get the benefit. And they also offer this Kubernetes deployment structure, the app.yaml file, so you can deploy into Kubernetes also. So there are plenty of benefits when it comes to microprofile as well as Helidon. So please, I would recommend you experience the whole frameworks and the specification, and you also contribute to the community. Yeah, that's all I have today.
Thank you so much, everyone, for joining in to our live stream today. Thank you, Tom, for guest speaking. And I'm going to end the broadcast. You guys can watch this uploaded on our YouTube channel tomorrow. Thank you.
Thank you.